Hey guys, so welcome back. So let's start another pretty cool lab. This time is gonna be another .NET binary, which is gonna be deobfuscated, following our Carnita methodology, and well, it's gonna be a little bit more difficult, and we're gonna be increasing the challenge, right? So that it can be more helpful for you guys to understand more advanced stuff. Okay, so the first thing I really want to show you guys is a quick recap on reflection, right? So you remember quickly we have a load file or load, which is going to be able to load binaries from disk, from resources, from download, from internet, whatever, and then from there you call a get type, which is basically going to give you a class, and then you can also call get types, which is going to give you all the classes from that specific object, and then from there you can call create instance, pass that type that you got, the class. In other words, you get that class, you instantiate that class, and you get the object. And finally, with that object, you call the invoke member, which receives as a first argument the method to execute, and this argument, the object, that it was instantiated, and the arguments, right? So this is very important because this way we know these TTPs, we know these indicators. So when we are doing analysis, we really know what we are really hunting for those. If we see a load, if we see a create instance, we know that we're very close to see a binary being loaded in memory, which is what we really want. Remember, we really want to move fast in order to dump the binary as soon as possible, and then get into the Carnita, which is the real malicious code, and then analyze it, right? Okay, so let's start with our binary. So I'm gonna open it up here. So we go to here, labs.net number 2, and we load it up. As you remember, guys, when we are dealing with .NET binaries, depending on the version, sometimes we want to run different versions of .NET frameworks than the ones that the malware was compiled with, and then we just need to add the same binary, create a file with the same binary name .config, like this, and we just put the version that we want to run. In my case, I'm using framework 4.0, and that's the one that I'm using. And this is also important because that way you can debug it in dnSpy. Otherwise, you're going to send an error. And then here it is, open it up, and we can see quickly here that it is been actually compiling with .NET version 0, but that's why we also, if we want to use it with .NET version 4, that's why we put that config file. Okay, so quick overview as recommended. We can see here there is resources. Those resources it is telling us that maybe these blobs are going to be loaded eventually in memory at runtime. It has 3 different blobs, and this is good to know, right? So we need to keep an eye on that. And then we have here the namespace with 2 classes, and then as usual, I just right click on it and set go to entry point, and then we're ready to go. Okay, so the first thing we're gonna do here, guys, is we're gonna do a static analysis, which is one of the features I really want to show you from dnSpy, right? Because with dnSpy you can rename variables, you can rename methods, which is actually pretty cool because it's like documenting your understanding. Now, following our Carnita methodology, guys, you really need to go and move really fast. You don't really need to understand this whole thing, as you know, but just as an exercise, and because once you get into the meat, into the Carnita, you will definitely need to understand every single instruction of the malicious actions. So these techniques that I'm going to be showing you here is going to be very useful for you. So that's the only reason that I'm doing it. Not because following our methodology, but just for you to have more skills in your background. Okay. So then let's go here. We click here in this function. We get into this other function, which, as you can see, those are very, very hard to remember names, and because they are obfuscated. Okay, so we have this function here, which is this one, and that one is going to receive 3 arguments, you know, those 3 arguments, and then this is the first argument, which is an X, which is, we can see here, is an activator class. Okay, if you remember, guys, this activator class is part of our reflection classes. Okay, then it's gonna get this Z, create instance. Okay, if you don't remember, a quick look here, activator and instance, right? As I told you, these are great indicators for us, because now we are thinking, oh, maybe this function is gonna be loading eventually, it's gonna be creating the instance of the object, right? But then the third argument is this object. This object is gonna be calling this function, and then it's gonna pass it to the get object value. So let's go here, because as you know, the execution is going to be from inside out. So this is going to be first executed, and then the upper call to the function, right? So we go in here again, and now here we can see that there is another indicator. Here is the load. You remember, right? There is a load, which is normally used to, you know, is a method used to load binaries in memory. And then here we have another call. This call, guys, here is exactly the one that we saw previously. I mean, it's being called twice. Okay, and then and actually I want to really show you another feature pretty cool from dnSpy here. So for example, let's say that you don't know this function, you don't know who is calling it. You know what is known as X references. So if you want to know which functions are using or calling this function, you just right click and do analyze, right? And then dnSpy is going to tell you, okay, so in the use by, you know what, that function is being used inside here. For example, you know, if we click here, you can see that this tsw is this guy, you know, is this method, and it's also being used here, you know, which is inside this ZVAK method, you know, and that's pretty cool because sorry, I think let me check this method. Oh yeah, sorry, yeah, this method, and this is pretty cool, guys, because we can go all the way back to all the call stack to know exactly which function calls which one, and that is going to help us to understand the full flow, right? Because for example, if from here I said use by, okay, and who calls this function ZV? Oh, you know what, it's called by main. Okay, we get to the root, so then we can trace back all the calls. Okay, so that's also pretty cool feature when you are doing analysis. Okay, so now we are here, and again we have another object in the middle, which is the third argument to be passed to this function, as we know. And this third argument, we need to know what it is. So again, since it's inside out execution, let's go inside this guy and see what's going on. Okay, and again, guys, you don't need to do this whole thing for the deobfuscation part, but it's very important when you are doing full analysis on the malware. That's why I'm kind of teaching these techniques. Okay, so now here we see, guys, right away a get object on this name, this string. If you don't remember this string, let's go to resources, and we can see that this is the F9. Okay, so it is this resource. So let's see what is inside this call. We click here, and we can see that this call is going to call resource manager, which is going to get the base name, which is the name of in the resources, which is the root base also. And if you don't know the parameters, you just put the mouse over the functions, and you can see that the base name is the root name of the resource file. Okay, so we know that now this resource file is here, and that one eventually is going to load F9. Okay, so then here we can put right click and say edit field and say something like get resources, for example, get resource, right, whatever you want to call it. Enter, and then dnSpy is going to rename it. And the pretty cool thing about this is that now here you can see that we have the get resource, which is more readable for us, and finally it's going to load here, right? And that's going to be loaded into an array. Then the array is going to go into the for loop based on the length, and then here we're going to have the left side and the right side, and eventually call the XOR. If you remember, in .NET XOR function, it called it the left argument and the right argument, which is basically the arguments that the values that are going to be XORed. That's it, right? So in the left side is going to use the every single byte being read by the blob that is receiving from the resources, and in the right side is going to get this array here at the position I, but now let's see what is this array. Okay, so we see that this array is a set of bytes, right, that are going to be like the XOR key. And then we can now right click here, say edit field, and we can put this something like XOR key, for example, right? And again, it's now renamed. We come back here, and again, now we have a more readable code. And then after that, it's going to do the XOR, and it's going to save it back into the array. So we can see clearly and easily here now what's going on. So I can now call this method, edit this method, and I can say probably something like here is doing the resources. We can say the code binary. Assuming this is a binary, we don't know yet, but assuming this is a binary, we call it the code binary. Okay, so now we come back, and now we have this guy already understood. Now we have the proper name, and now we know that here is passing the first argument as we saw, which was, let me remember, it was assembly. Then the second one here was the load, and then the third one was the binary itself loaded. And if you remember, this load is going to be eventually being used by assembly to do an assembly.load, and then eventually it's going to load the binary. As you can see, they are creating dynamically everything. Okay, once they do that, they get this object, which is loaded in memory, and then they pass it to another function which is called new late binding, late get. They pass it this object, and then they pass it the get types. As you remember, the get types is to get all the classes for that specific assembly. Okay, and now if you remember in the previous class, guys, we talked about the late binding. So basically you have what is called early binding and late binding. Binding means to bind the classes, the methods, the arguments, all to the binary. So basically when you have early binding, that means that you have your classes, your methods, your arguments, your type of arguments, all of them statically created, and at compile time it's gonna be, create the binary, and then all those classes, methods, and types, arguments are known by the compile. That's early binding. But let's say that you wanna load a class in memory through reflection, and then from there you're gonna get the object classes, and then the arguments and the type of arguments. That is at runtime. There is where you use late binding, okay? And those functions, late get, are exactly for that, which makes sense because we are doing, the malware is doing reflection here, right? And that's the reason we're calling late get. So, and here is gonna get the get types, which is all the classes from that assembly, and then here finally we can edit this function and say something like, I mean, you can go crazy, but whatever it is clear for you. Load, which is gonna load the binary, and then it's gonna get the types. So we can say load get types. Load get types, something like that, right? Whatever you want to call it. Okay, so we come back, it is renamed, and now when we go back, guys, we now have, as you can see, we have this properly labeled load get bytes. We have now here inside this function, which we know is going to call this for 3 arguments. The third one we know now is decoded binary, and then finally eventually this guy that has now the classes, right? No, sorry, no, I'm not reading it properly. Yeah, so this load get bytes, which eventually get the bytes, is gonna be called here. Yeah, I was in the wrong place. So here, this is gonna return, the classes for that assembly, and then it's gonna call this guy, which is the activator, and then this guy, which is the create instance, and it's gonna pass that object that has the class ready to be instantiated. Okay, so now that we understood quickly this whole thing, still this is the function that eventually is going to do the whole thing. It's also a late binding that I just explained, and we're going to see it in a second how it works. But specifically what as we are seeing is going to call classes, methods, and arguments, right, which through reflection. Okay, so now let's go quickly to the entry point. Right click here, go to entry point, and then I'm going to put a breakpoint here, and let's start debugging it. What else? So before doing that, guys, I really want to show you how you can, this whole thing, you can save it, and I want to call this guy dash 2, and then I'm going to save it, okay? And I'm going to close this guy and reload it, remove. So now we have here, as you can see here, we have the L2, and we have the L2 config also. This is pretty cool. As you can see, here is the L2 created, guys. And now, if you remember, we need to create a config file for that in order to run. Okay. Let me see. What is this L2, guys? Do you remember? I don't remember. So I'm gonna remove this. I don't wanna be confused. Oh, no. That's the one that we just created. Okay, yeah, this is the one that we just created. And then here, guys, we have the config file. You see, ready to also be executed, right? So this is pretty cool actually, because far, as soon as we create this guy, it creates the config file automatically. I don't know if it is far or if it is dnSpy, but anyways, it's created for us. Okay, so now let's come here. I'm gonna open it again. Now the version number 2, and as you can see, this version number 2, I do right click, go to entry point, and you can see that we have all these guys properly labeled as we see it, and the binary is still running perfectly. That's the beauty of this whole thing, guys. Okay, so now let's put the breakpoint as we said in the entry point. We put it here, we set play, entry point, okay, so we are there, but let me see, yeah, we're there. Okay, so now we do F11 to step into. Okay, now here is what we analyze statically, guys. So let's just look quickly to validate the XOR. I'm just going to show you the XOR. We're in the load. Here, as we know, it's going to load the decoded binary. But before that, it's going to enter into the to string. I'm just pressing F11 to step into. This one is the to string. I don't want to step into that. I do step out. Okay, and then I do again if F11, we get into the decoded binary, guys. As we know, this instruction is going to load the binary in array, so we do F10 to do a step over. I don't want to get in, and you can see here, guys, here is the array. If I try to expand it, it says, hey, there are many items. You want to really do it? I don't actually. So I want to just do a right click, show in memory. You can pick any memory view, and you can see here is the whole blob from resources highlighted, and you can see clearly it is some sort of encoded, right? So but it is loaded. Okay, from there we're gonna get into the loop, and so let's just quickly go to the left. You see here is the left. The left is gonna get the first value of the array, which is 07, and I forgot to show you that one. Let me just quickly show you the 07. You can see here the first value is 07, then it's going to be 09, D9, and that's going to be the loop, right? Iterating through all the bytes. And then in the right side, as we saw, it's gonna get the first value of the XOR array, and then we have the left and right, and as you remember, it's gonna be XOR. So if you are thinking that this might be a binary, which do you think should be the result of this XOR? You remember the MC header in a binary? Okay, so that's actually an M, right? That's an uppercase M. So that should be it, right? So let's do it. So we do an X, we do 0x7 XOR with 0x for A, okay? Okay, and we got the 4D. You know what is 4D, guys, in hexadecimal? If you don't, I highly suggest, guys, if you're trying to be reverser and you really wanna memorize all the hexadecimal values, at least for the alphabet, for the ASCII numbers, special characters, and letters, because that's gonna save you a lot of time, and that's gonna also help you to spot whenever you see interesting strings in the binary. Okay, so this is the letter M. Okay, so let's do the next round just quickly so that you can see the next one. The next one is gonna be expected to be Z, right? Uppercase. So we can see here again, we see that this is 53, and then we have 09 here, and 5A again, guys, is, you guys what? Oh, sorry. Okay, is the letter Z. So now we know it is basically doing everything. Okay, so now I want to put a breakpoint here in array, so I know how it works. So let's just get out of it. We get out, we get into the array, we right click again into show memory. Okay, here, guys, it's very important to right click and click on refresh, and we can see that boom, we got the binary. Okay, at this point, guys, we can just dump it. You know, I can go here, right click, save, and basically I can just dump it, right? I want to do a stage2.bin, whatever. Okay, and let's open it. Okay, we open it up, and we can see that here is the binary. The name is IE. It was detected. It's supposed not to be detected by my thing, but anyways, that's funny. Anyways, we'll see if it allow us to run. And here is the whole thing, guys. You can see it here. You can see it that it has this you know, these classes, IE, mexecute. If you go there, you can see the carnita, you know, which is basically the logic behind. Everything is here, but as I told you, we don't wanna do a deep understanding of this. It's not the scope of this lab. The scope is just to do the deobfuscation, right? So, but it is there. That's great. Now, in order for you guys to fully understand the whole thing, I just gonna step into the other execution so that you guys really see this create instance, how it's been executed and everything. So, and that's the only reason, because as I said, we should go faster in this when doing the deobfuscation. So I do F11. So we get here, guys. So that now we get into the late binding, and let's get in. And here, as you see, we're passing the assembly, we're passing the load, and we're passing the blob. The blob is the one that we just decoded from memory, the binary. I do F11, and I'm just gonna quickly go step F10, which is a step over, because I don't wanna step here. I just wanna get quickly into the place. So here we have the object late get, and here is pretty clear. We have the null as an instance, we have the type, which is assembly, we have the member name, which is the load, and we have the arguments, which is here, guys, which is the blob. You know, here is the blob. So easily we can right away see that what we're gonna do here is gonna load assembly memory. So we do F10, and you can see that right away we have now here the IE, and as you remember, this IE was the name of the function. Here is the entry point, and we have the name of the function that we just here you go, that we just open, right? The one that we dump it right here. Okay, so everything matches perfectly. So then I do F11, I get out of this, we come back to this place, and then it's gonna do a get types, guys, here. Okay, the get types is gonna get all the classes. I'm just gonna skip it because it's exactly the same thing. I do F10, and then from here we get back into this original one, right, guys? So this original one, guys, what is going on is that we're gonna pass the class, and we're gonna pass the X and the Z, which is activator create instance. So again, let's do F11 here. We go again inside the late binding. We go again all the way to the place where it's gonna be called. Here you go. Here we are ready. We got the instance is null. We get the type is activator. We get the member name is create instance. Okay. And that's pretty much. Basically, what is going to happen here, guys, is going to create an instance, and then it should call invoke member. As you remember, that's exactly what happens here. Create instance with the activator class, passing the type, that we just get the type, and then get the object, and eventually call the invoke member. Okay? So, let's go back there. So let's see what happened. I'm gonna do F10 here, and see something very interesting, guys. We do F10, and as you can see, this guy is running. It didn't stop immediately. This means this guy is doing something, and in other words, the malware is already running. But we saw that first is create instance, and then is called invoke member, right? What is the reason it just started executing right away? So there is an explanation for that. If we go to this to our classes, here, guys, if we go to the entry point, you can see that the main actually doesn't do anything. However, we have this function called static. Static is a function that when it is defined, it's gonna be executed before main. So, and therefore, as soon as we instantiate the class, this guy is being called. And that's the reason that it gets executed right away, okay? It's important to mention that because sometimes you put a breakpoint in main, and suddenly you see something executing, you see even your system getting infected, and you said, but when that happens, you know, is because of this static. In the Windows binary that are not .NET, it is called TLS callback, which has the same functionality. Anyways, so that's pretty much it, guys. Now, what I'm gonna show you now is gonna be another way to dump the binary, okay? Which is very important also. So I'm gonna remove this guy. I'm gonna remove this guy, okay? And then I'm gonna open it again, the original one, okay? Here is the original one, which doesn't have anything documented. I do right click, go to entry point, okay? Let me just close these guys because, okay? So, as you remember, here, eventually we go here, which was the load, which calls the XOR here, and here is our array, right? So what I'm gonna do, guys, is I'm gonna patch this binary. We don't, and this is pretty cool because we don't need to have the source code because it's already decompiled. So we can go to the malware, like here, guys, and do an edit method, okay? And then we can actually put anything we want that we want to alter. We can print variables, we can print content that we want to analyze, we can dump information, anything that we need at runtime, we can do it, which is pretty cool. Sometimes there is this dumping of the binary in memory is very obfuscated. We don't see it clearly. Sometimes it is calling a DLL that is loaded in memory, decoded, and execute the dumping. So it's not that easy sometimes. So what we can do is, you know what, I know that in this piece is decoding from memory, just dump it on disk. Is what we're gonna do here. So the exercise that I'm gonna do is gonna dump this array on disk, just to show you how it can be altered, and most important, the dumping can be in a different way by doing this exercise. We don't need to copy paste this in Visual Studio, compile everything, which is a total mess. It's just right there, patching, great. Okay, so let's do it. So for this, I'm just gonna use the system.io.file .write all bytes. Okay, is this one, and this one receives as an argument, as you can see there, the path. So I'm gonna put the path where I wanna save it. Okay, let's put it here, stage, or let's put it, here, stage 3 or 2, just to differentiate it. And then I'm missing another backward backslash, and then comma, we put the array of bytes that we want to dump, and that's it. Okay, so we do compile. Sometimes it's gonna have these warnings, we don't care about the warnings. Sometimes it's gonna have some errors like this one, so we double click on it and it takes us here to the com import. It says that the GUI attribute must be specified within the com import attribute. I don't have an idea what's that, but we don't really care about that. We just really wanna execute it with that modification. And if so, we comment it out, this guy, and if we comment it out and it just break the whole binary, so we need to go deep into understanding the reason and then eventually fix it, right? But here we just compile it. It closes the windows, which basically means that it compiled successfully. So the next thing we need to do is we need to save it. Okay, I'm gonna overwrite the original one. Okay, and then I'm gonna put a breakpoint. Go to entry point. So I'm gonna put a breakpoint right there, where we put our dumping strategy. It's right here. Okay, I'm gonna put it there, and I'm gonna do start entry point. Okay, see here, it gets to the entry point, then we do again play, so we get here, so we do F10 to step over. Okay, and then let's see if that guy was saved. So we save it in CCW, it is there. Okay, we open it with Hue with Alt F3, it is there. So let's now open it back here to see if it was dumped successfully. So we do open. Oops, maybe it's not there. Maybe. Oh yeah, it basically the thread detects it, but it doesn't remove it. So anyways, we don't care about that. So it's here, guys. You can see it's properly dumped. So that was the second thing that I wanted to show you, right? So you can see that we can even patch inline with dnSpy, recompile it, and it's actually huge because we can modify code as we go and in our own purposes, So that's pretty much it, guys. See you in the next one.